Okay, so use Google Maps to estimate the value of pi. Okay, so so I'll go to Google Maps. So I click on Google Maps. Okay, and I choose, something, anything circular. Okay, so this is New York. Let's see, Prospect Park. Let me see something. I don't see anything circular in New York City. You have to pick something circular. What is this? I don't know. Okay, let me go to. Okay, I see Prospect Park. It's not circular, but more or less. What matters is that I show you how to measure the distance around the park. Okay, so the perimeter. Okay. So what I'm going to do, I'm going to put my cursor somewhere. Okay. At a starting point, and I'm going to right click. Okay. And then choose the option measure distance. All right. Okay. And then I put my cursor somewhere else and I click, and it measures the distance between my starting point and the new point. Okay, and I put my cursor somewhere else and I click, left click this time, okay? And I measure the distance. You can see that it's in feet here. But at the end, it's going to convert in kilometers, the metric system. It's going to give you values in both systems of units, okay? The English system and the metric system. I may want to get a bit closer. Okay. Or you can see already that it does, right? Can't you? 2,800 feet is 64 meters, 864 meters. And I keep going, okay? So the end of the park is here, on that side, and I keep going here. It keeps measuring the distance around the Prospect Park. Is this part on the right part of Prospect Park, or it's not? I have to go through Flatbush Avenue. Does anybody know? Brooklyn Botanic Garden, is that part of Prospect Park? Nobody is from Brooklyn? Okay, doesn't matter, I'm going to include it. Okay, I keep going around and around. Okay, around. Okay, and here, oh, what am I doing? Okay, all right. Looks pretty nice. This side looks very straight, so I don't need too many points. I can just put the next point here at the corner. See, that's more convenient. This also looks straight. The next point can go here. This looks straight. The next point here, and then I connect with the end, and I get the total distance, the entire perimeter of the park, which is 3.9 miles or 6.41 kilometers. Okay, so that's what you're going to do, but we have to do it with an object that's circular. Obviously, Prospect Park is not circular, so it's not a good choice for your lab. Okay, so you have to do it with something that's circular. It's just that I can't find anything that's circular here in New York, unless maybe, yeah. Okay.
How about Columbus Circle? Isn't it?
Columbus Circle. Okay, so let me Google that. Columbus Circle. Okay. That's Where is Columbus Circle? It's 59th Street and what? Oh, this. I see. I see. Oh, yeah, that's circular. Okay, let's measure the distance around Columbus Circle. That's a very good choice. And then we'll measure its diameter. Okay. So I start at 8th Avenue. Okay. And the Columbus Circle. And I right click. And I have to clear my previous measurement. Okay, clear measurement, because I'm going to start a new one. Okay, so right click. So I'm starting at 8th Avenue. You can start anywhere you want. Okay, right click and choose measure distance. Okay, and I get my starting point. Okay, and then I need another point, and another point. But now I need to go into small steps, okay? Because this is circular, right? More or less. Okay, so I need small steps. Otherwise, I'm not gonna get an accurate estimate. Okay, so small steps. I go around Columbus Circle. Okay. So that's what you're going to do. And if you can't find anything circular, if you can come up with something circular that you know, anywhere in the world, the lab has a few, it gives you a few choices, okay? It gives you a list that you can choose from of a few objects that are circular, more than 10 objects. So now we have the distance, we found it, so that's 811 feet, wait, yeah, 811 feet, yeah, that's correct. 811 feet, okay? So that's the circumference of Columbus Circle. Does that make sense? Now you need to find its diameter, okay? Okay, you need to find its diameter, okay? So I'm gonna zoom out, okay? And I'm gonna start a new measurement here. No, I have to clear this, clear measurement. Okay, now it's diameter. So I start here maybe, okay? Right click, choose, so right click, choose measure distance again, and I get a new starting point, okay? You know what a diameter is, right? It's a line segment, okay? Whose ends are on the circle and that goes through the center. Let's say that the center is somewhere here, right? So we have to manage to go through the center of the circle. But it's a straight line, so we can do it at once, okay? We don't need to do it, we don't need many steps. I'm gonna put the next point here, okay? And hope that it goes through the center. That looks good, right? So, and I get 252 feet. So you see how it works? 252 feet. Okay. So if I divide, what did we find for the circumference of Columbus Circle? Anybody remembers? It's 800 something, right? Somebody sent a chat. 811, okay. So 811 divided by 252, I get 3.21, okay? Which makes sense, right? Because remember, so, the circumference, maybe I can use the whiteboard. Okay, so the circumference of a circle, right, equals What's the formula for the circumference of a circle?
Pi times the diameter.
Yes, that's correct. 2 pi r, okay? 2 pi r, right? 2 pi r. But as you said, 2 times the radius, r is the radius, twice the radius is the diameter, okay? So we get, oh, the eraser is here. So we get, okay, no, what is the thing? Where's a pencil? Draw, okay. No, is that, okay. Okay, so we get pi, okay, times 2 times d, 2 times r is the diameter, right? 2, and this is the formula we're going to use, okay? Circumference is pi times the diameter, right? So that means that circumference divided by the diameter, if I divide both sides by the diameter, I should get, of course, I should get pi, okay? I should get pi. And that's why when I took 811 and divided by 811 divided by 252 for Columbus circle, okay? 811 being the circumference divided by the diameter 252 feet, I got 3.21, okay? Which is close to pi, okay? Because Columbus circle is not a real circle, okay? But even with a real circle, because you will be doing everything by hand, you will not get exactly pi, or if you are a little bit off, that's fine. Okay, so don't worry about it. Now, so I think you understand how to do this. Now, observe that this formula, okay, this formula that I'm going to put in a box, okay, circumference for the circumference. Okay. This formula in a box, that's the formula we're going to work with. It's a linear relationship between circumference and the diameter, okay? You can view the diameter as the x variable, so it will go on the x-axis, and the circumference as the y variable, so it will go on the y-axis, the vertical axis, okay? In that case, you have y equals pi x. See that? Y equals pi x, or c equals pi d. Okay, so maybe text, maybe y equals pi. It's not gonna write pi, so I'm gonna write pi, or pi is 3.14. Okay, x. See, that's the linear relationship we are talking about. Y equals 3.14x, okay? Or C equals 3.14D, okay? So Y is the same as C, X is the same as D, okay? And you see, and what is the slope of this line? Of this straight line? If D is the independent variable, so basically X, and Y is the dependent variable, basically. And C, so D being independent, therefore X, and C being dependent, therefore Y. What's the slope of this straight line? Yes, 3.14 or pi, okay? And that's what you're going to do, okay? So how are you going to do it? Of course, you're going to have many measurements, okay, of different objects, so Columbus circle and many other circles, for which you will measure the circumference and the diameter, okay? The diameter will be the X value and the circumference will be the Y value, okay? For a particular object, there will be a particular combination of diameter and circumference, and that will be a data point, okay? For another circular object, you will have a diameter and a circumference, so X coordinate and Y coordinate, and that will become another data point, okay? And then you have to plot all those data points and draw the linear relationship between the two variables, okay? Let me give you an example. Let me open my Excel file. Can you see my Excel file? I want to make sure, can somebody answer in the chat room or anywhere? You can see my Excel file, no? Okay, let me share it then. You cannot share it, you can see it. Can you see my Excel file now? Yes.
Yes.
Okay, good. Okay, perfect. All right. So let me plot two things. Maybe age, somebody's age, and somebody's height. Okay? So age being the X and height being Y. Understand? So for somebody, one of you maybe, okay, when they are 2 years old, how tall were they? Maybe 15? I don't know what the unit, doesn't matter what the units are. Okay, this is just an example. When they were 5 years old, how tall were they? Let's say 56. When they were 8 years old, it doesn't matter what the units are, okay? This is just an example, okay? So, yeah, it doesn't matter what the units are. When they are 8 years old, they have a height of 71, okay? When they are, I don't know, 11 years old, they have a height of 100. When they are 13 years old, maybe 140. When they are 15 years old, maybe 146. 17, 180, okay? 19, 188, 20, I don't know, 209, okay? At this stage, all I have done is plot the data points, okay? 215 is one data point, 2 being the X coordinate, 15 being the Y coordinate, okay? 556 is another data point. 5 being the x coordinate and 56 being the y coordinate. Okay. 871 is another data point, 8 being the x coordinate and 71 being the y coordinate. But at this stage, I do not know whether the relationship between the variables age and height is linear or not. Could be linear, or maybe it's not linear, okay? To determine that, I can use Excel, okay? So I'm going to select the entire table, okay? I can even give it a name, okay? Sheet 1, I call it table, okay? My worksheet. I named it table. Double click on it and change the name, or right click on the name sheet 1 and then change the name. So I'm going to select the table, including the titles at above, and I'm going to go in the menu insert, okay, and choose the scatter plot. Insert scatter, okay, because this one is very convenient for plotting relationships, okay. And I choose the first one. Here you go. And I have height. You see, height against age. And do you think there is a linear relationship between the two? Do you think that these data points seem to be approximately on a straight line? Yes.
Yeah.
Yeah, right. They seem to be. Yeah? It doesn't look like a parabola, right? Or it doesn't look like a logarithmic function or a sine function or any trigonometric functions. It looks more like a straight line, okay? So then we can say, or approximately there is a linear relationship between the two, okay? Now, we want to find the exact form of that linear relationship, okay? So what I'm going to do, I mean, you can do it here in the same sheet, in the same worksheet as in the table, but I find it, you know, a little bit more convenient to work in a different worksheet. So I'm going to move my figure, my graphical representation, in a different sheet. So I'll right click inside the figure and I choose move chart and new sheet, and I can give it a name. Figure, maybe. Okay. And here it is, okay? If you want, you can change the title. So let me move this. So you click on design, menu design, choose add chart element, okay? And axis titles, okay? No. Chart title, okay? Chart title. And then you can choose wherever you want to put your title. Above the chart, maybe, okay? All right, perfect. Okay, this thing is bothering me. So here is the title. I'm gonna call this relationship between height and age, okay? For example, you can call it whatever you want. I have a title for it. Now, can you still see everything I do? I just want to make sure I'm not losing anybody. Okay, good. Now, you have to click inside the chart and design and choose a axis title, okay? Yeah, primary vertical. Okay, I want to call this height because that's the y-axis. Okay, that's good. Maybe I can make this bigger. This looks a bit small. Size maybe 16, maybe 20. Perfect, 28. All right. A bit big though, a bit big. Okay, perfect. Now, design again and choose for your horizontal axis, primary horizontal. Here it is. Double click in it and call it edge, right? Or whatever you want. Looks a bit small. Maybe give it a bigger size, 20 again. Perfect. Okay. No. Somebody asked, do we have to use height and edge? Of course, for you, it's not going to be height and edge. It's going to be circumference here on the vertical axis and the diameter on the horizontal axis. That's what it's going to be for you. It's going to be circumference and diameter. I'm just giving you an example of height and edge just so that you know how to find the relationship, because the interest in your lab is to calculate the number pi, okay? And the number pi, if you remember the whiteboard that I showed you, is the slope of the straight line, okay? The slope of the linear relationship that exists between the circumference and the diameter of a circle. Because if you remember the formula was C equals pi d. And you told me that the slope was pi, 3.14, okay? So that's, this is just an example to show you how to find that slope, okay? But for a different problem, for the relationship that exists between height and edge. We want to find for this person what the slope is, okay? To find the slope, you go in the table and you right click, okay? You choose a data point. You have to choose a data point, okay? You right click on a data, you choose, so you click on a data point and automatically all the other data points will be selected, and then you right click, okay? When you right click, you'll be provided a list of options. Choose add trend line. Click on it. Yes, I just added the trend line, but this is hiding one. Okay. So now choose of these trend lines options. You told me that the relationship that you saw between the data points seem to be on a straight line, right? So therefore, the trend line should not be exponential. It should not be logarithmic, should not be polynomial, power, and so on. It should be linear, because you told me that it's the data points seem to be on a straight line. So I choose linear. And then I choose set intercept. Okay, set intercept. Well, you choose the intercept because a straight line has a slope and a y-intercept, right? But what should the intercept be for this case? Okay, you don't have to choose the intercept. Okay, but in this case, I'm going to force the intercept to be 0, because of course, if somebody is 0 year old, they have no height. So the data point has to be 0, 0, and therefore the straight line has to go through the origin. So it has to go through 0, 0, right? And for you, let me ask you, for you, what will the intercept be? Will you have to force the intercept to be any number? And if so, what will that number be?
0.
Who's intervening?
I cannot.
Yes, what do you think the intercept will be?
0.
Why? That's true, that's your correct answer. And why?
Because if the what's it called, the diameter is 0, then the circumference would be 0.
That's correct, right? A circle that has no diameter has no circumference because it doesn't exist. Okay? If the circumference is 0, the diameter is 0, and vice versa. So therefore, the intercept has to be 0. Okay? So the straight line describing the relationship between circumference and diameter has to go through the origin. So you force the intercept to be 0. Okay? And we want to display the equation on the chart because we want to know what the slope is. And then maybe you can display the r squared value on the chart. I'll explain what that is. Okay, you don't have to do it for this course, but it helps. It helps to know what the r squared value is. Okay, so let's see our results. Here they are. You see? So my equation is y equals 10.133x. Okay, which means that the slope is what? What is the slope for this straight line? The straight line shown by these dotted line, these dotted points, by this dotted line. What is the slope?
10.133.
Right. The slope is 10.133, and for you, it has to be, or it has to be close to 3.1415, right? Close to pi, right? If it's a bit off, that's fine. If you find 3.0, 3.2, 3.1, 3.3, that's still acceptable, okay? Because the objects that I'm measuring will not be real circles, probably not, okay? Real circles. Plus, you're doing everything by hand. Plus, when you measure the diameter, you're not sure that your line segment goes through the center of the circle that you've picked on Google Maps, okay? So, but you know, what matters is that you do the exercise, and what matters is not to get an accurate value of pi. What matters is to understand how measurements are done in physics. Okay. All right. Now r squared. What does it mean? This comes from statistics. What we are doing here is statistics. Okay. Inferential statistics. R squared, when r squared, okay, we call that the coefficient of determination. When it's close to 1, that means that the relationship that exists between the variables, okay, is fully linear. Or close to 1 means that it's close to being linear, okay. And graphically speaking, that means that the data points are very close to the line of best fit. We call this dotted line the line of best fit, or the regression line. Okay, the regression line. Okay, so that's the advantage of having an r squared, because it shows you how well you did your work. Okay. So in our case, 0.9854. You see that's close to 1. No, you have to use Google Maps. Somebody asked whether we should compute the diameter using Google Maps or using the formula. No, you have to use Google Maps, okay? You're measuring everything using Google Maps, okay? Okay. I think that's it. So the slope is 10.133 here, but for you, it will be around 3.14, right? Because that's the slope, but because that's the value for pi. And then, of course, you'll save this, and then you'll attach it to your lab report. Okay, I think I can stop recording now. But you know that, yeah. Okay, recording.